Here. All right. So, all right. All right, so let's talk about server-side functionality. These are things running on the server that help make your web application run. Now, like I say, originally it all started with static content. You just had pages with images and HTML text, and everybody would see the same thing up there. But nowadays, everything is customized content. Each user has a different experience. You certainly want them all to see different ads, and you probably want them to all see different content otherwise. Like when I go to Google News, it puts the news I've selected as more interesting to me up the top and takes off the stuff I don't care about, and that's how it goes. So you've got scripts on the server that are taking parameters from the user and customizing the content. So you have to send up parameters. Now you can put them in the query string, right in the URL. That's one place to put them. You can put them in the file path of RESTful style URLs, which amounts to the same thing. You can put them in cookies, and you can put them in the body of requests using the post method. And all these things are used to send information up to the server to tell it exactly what you want, because it's not as simple as I'm going to yahoo.com and that's all you need to know. It needs to know a whole lot more to customize that page to be the way it should be. So it can, in principle, your application can take any part of that request and use it as an input and customize the page based on it. It doesn't have to stick to the expected parameters. You could use anything. Like you could use the user agent and show different things, and that's commonly done. So if people are on a mobile device, it will look at the user agent and try to figure out how big the screen is and then customize the page to look good on that small screen. That's very important these days. So you've got applications running scripts on the server that are harvesting this data from the request and deciding what to send out. And so they're using PHP or VBScript or Perl or platforms like ASP.NET and Java, which are important at big shops because they scale to gigantic server clusters and global clusters and everything. That's why people put up with all the painful difficulty of Java, because it scales to huge. If you really have, if you're really Google and you have 100 million requests, I don't know, in an hour or something, you can't just use simple little PHP scripts anymore. You've got to use stuff that scales. And then Apache IIS and Netscape Enterprise, I don't know if that's still around, but Apache and IIS are still around. And databases are running, holding your data. And you got other back systems, like SOAP-based web services used a lot by mobile devices, where you can request a little bit of data and get a little bit of response to get information. So like get a profile to show you in your phone. So Java is the standard for large-scale enterprise applications. Java is enormously difficult to use, very buggy, it crashes a lot, it has unbelievable problems, and huge security problems, in addition to huge usability problems. And people put up with all that, just like they put up with the baffling complexity of Microsoft's Active Directory, for the same reason, because if you are a huge company with thousands of employees and machines, you need all that stuff. And it's worth paying staff to figure it out, because nothing else scales to the complexity of real business. I mean, for example, suppose you are Yahoo and you decide to buy eBay. Now you've got 100,000 machines you have to integrate in the network, and there is nobody there for you but Microsoft. They are the only company that makes a system to handle my 1 million users, plus the 100,000 I just bought, how to connect them together so all these people can access resources over here, and I still know who everybody is, and I've still got them sorted into administrators in the various levels. Microsoft has figured that out, and they've sold you stuff that can really do that, and there is nobody else playing in that space. So anyway, that's what these huge platforms are for, enterprises, big enterprises. So there's a bunch of Java platform terms. There's enterprise Java Bean to enforce your business logic, like transactional integrity. This is what caused the disaster of Ethereum. Transactional integrity is if I spend money, it goes from this account to that account. It's not going to add to this account and then have some later operation that might fail, subtracting it from that account. That's what happened to Ethereum. You could add money here, and then there's a later transaction that took it away from here, that you could do this 100 times too fast for this to catch up and create money out of nothing. That caused the collapse of the Dow and Ethereum last month, trashing the #2 cryptocurrency in the world. There's plain old Java objects and Java servlets, different kinds of Java applications, and Java web containers, which are just like Apache Tomcat. I've used Tomcat, and it just makes me want to cry. And normal Apache servers are good enough to serve a web page. Tomcat is just buggy and crashing all the time. One of the incredible things, the Wall of Sheep at DEF CON runs on Tomcat 9, Tomcat 7. The the packet hacking village that I run up there. I run part of it. I help run the packet detective part where people do hands-on training. And the thing runs on Tomcat, and I built a Tomcat server, and it took a half hour to start up, and I couldn't believe it. And I Googled the documents, and this is really true. Tomcat needs a random number to like set a cryptographic keys, and if you put it on a server, there's no randomness, so it takes a half hour to get the randomness. So you have to add an entropy application that creates entropy, and now it'll start in 2 seconds. And I read it, that's impossible. But it's true. The same thing's true in Microsoft. You get deeply into like domain controllers and stuff. There is stuff you wouldn't believe going on, and you really have to study and be an expert in it to really make it work for huge companies. They got problems that smaller shops don't have to deal with. Anyway, all right. So then you got third-party components. You might have things happening at the presentation layer with site mesh and other objects here doing relational mapping. There are various other objects floating around. The one I know that caught my attention a few years ago from Troy Hunt, who is an Australian security researcher, who is a hoot. You should follow him on Twitter. He's hilarious. He's a Microsoft-oriented server admin, and he's always finding great stuff. He found these Elma servers. Maybe I'll show you some of them. They're probably still out there. If you go to Google and you just search for Elma, I don't know what Elma is. I don't know who makes it, but it is commonly used for error logs of Microsoft servers. And what you can find is there are often people that have just made this thing public, hanging out public. These are articles about Elma, but I think, yeah, here's one, ASP session hijacking with Google and Elma. You can find it. There's a Google dork that will just show you people's servers. Like one of the major, I think Toyota just had their Elma server just blown in the breeze. So you can just connect to their website, and it shows the complete URL of every request if there's an error. So all you have, then you post a link, toyota.com'. Anybody that clicks on it, they'll show up in the error log with their cookie and everything. So this happens a lot. You're talking about your browser is full of all these components. The server is a group of a bunch of different servers running different technologies, written by different people, all running together to create the experience, and each one of them can make a mistake. And the most severe mistakes are the ones that are not as simple as bugs, where there's a mistake in the code and you can fix it. They're logic flaws. Like you have the server, it's supposed to log the errors, you're supposed to have something fetching the errors giving it to the developer, and it never occurred to anybody that there might be sensitive information in the errors. It's not like it's broken, but it's leading to a disaster anyway. ASP.NET is Microsoft's competitor to Elma. If you're a big shop and you use Microsoft domain controllers, you want to use Microsoft everything. Web servers and chat and everything should all be the Microsoft version as much as possible because it'll work better. And so you make your web application all run on Microsoft platform with .NET, ASP.NET. You can use C# or VB.NET, and you have a powerful development environment in Visual Studio, which is huge and constantly in development. And this becomes your specialty. And most of the big websites are using this, or they're going with Java. There's some open source ones, but they usually aren't the really big ones. Anyway, the Visual Studio and ASP.NET do have some built-in defenses because Microsoft is very aware of security problems, and they build in a lot of automated defenses. Now, if you get invited to the Blue Hat convention at Microsoft, they will pay you $100,000 if you find a significant bug in their product, and they will pay you another $100,000 for writing a good patch. And that is working pretty well. Microsoft stuff is getting better in a hurry. They're totally cooperating. They bought us all beer at TorCon 3 years ago. Microsoft gave up fighting the hackers and decided to accept them as partners. Anyway, so PHP is the source of an unbelievable number of vulnerabilities. My main website got hacked twice through PHP vulnerabilities so far by some of our smart students, and you should all do it too. If you hack me, you get extra credit and eternal fame on the Hall of Fame of people that hacked me. I thought they couldn't get on my main server, but I had a PHP script on there and they got in. So typically people, if they're open source, like small companies, they use Linux, Apache, MySQL, and PHP, which is the open source version of everything. And it's easy to use, but PHP tends to be insecure. It's very easy to make a stupid mistake writing PHP. You often have code injection vulnerabilities. You often have some way to change the name of the file it's getting written to. It just turns out if you have a page in reality and you put it up with LAMP and you develop it for a couple of years, pretty soon you've opened some holes and you get hacked. That's why everybody's WordPress blogs get hacked and all that. And you see, there's another one just today. Another bulletin board got hacked for the second time through a PHP bulletin board. There's tons of PHP-based stuff out there because it's so easy and fun to write, and it just tends to have a ton of security problems. And at least you have to update it. But even if you do update it, in practice, PHP has a really bad reputation for a good reason. If you use PHP, you're probably going to get hacked a lot. There must, in principle, be some secure way to use it, but that's not what happens in practice. Anyway, Ruby on Rails is a big hit. If you obey the rules strictly and you know their game, Ruby on Rails can even auto-generate a lot of code, so a whole bunch of people love it. It's got vulnerabilities too. I'm not sure if it's as bad as PHP, but every one of these has an endless chain of vulnerabilities and patches coming out. SQL is used to access relational databases. Almost everything that you want to store, that if you have any quantity of data to store, like products and customer IDs and balances and stuff, you put it in a structured database, a relational database. Relational databases are the most common type where everything is 100% accurate and tables are connected to each other. There's a new thing called NoSQL, like Cassandra, where you try to have a database where it's not perfectly in sync, but the servers have some update process going around in waves, like Facebook does it. So when you put up a Facebook post, it doesn't appear on everybody's copy of your wall right away. It sort of percolates through the world, and it might be a while before people in distant countries get it. And they tried to exploit that to get increased efficiency by not having everything in rigid lockstep, the way relational databases are. But most people still use good old relational databases where you make a record change and every copy of that record is changed right now and there's no question. Like it was intended for financial work, where it is really not acceptable that a change doesn't have immediate effect everywhere.
Right.
Yeah.
And you have like the whole, with that you have like even the rollback. You have like the
Right.
whole sequence where you're like, if you don't get
If it didn't work, then roll it back, yeah.
Then it's like,
If you're doing financial work, you have to know what you're doing, but there's other less precise things like
yeah,
Facebook
like
where
Facebook, like like your picture of you, your
Yeah.
selfie of whatever.
Yeah.
Like, that's
Yeah,
like
like
it
with
is.
big data,
Yeah.
they are becoming pretty much useless. So everybody
Yeah.
who have to work with big data have to switch with
Hadoop.
something like Hadoop or MongoDB.
Hadoop and Mongo, yeah. If you can learn any Hadoop and Mongo, man, you'll be employable. Everyone's jumping to it. Nobody understands it at all. Mongo in particular is fantastically insecure. Mongo, by default, has no password, listens on ports, administrative port is open, and they tell you in the documentation, don't expose it to the web. And there were a series of hackers that found like 10,000 Mongo databases connected to the web, where you can just take over everything. It's really a poor idea to manufacture a product and then put in the manual, don't connect it to the internet. You know, this is like handing you a gun and saying, don't let your kids play with the gun. I mean, somehow people go to jail for letting their kids play with the gun, but they don't go to jail for selling you software that you can't connect to the web. But they should. Anyway.
The PC Anywhere in VNC, like you used to be able to scan and just find like no password open machines.
Oh, yeah.
Like
Yeah.
just all day
Yeah.
long. It's like,
Yep.
oh, look, but I'm going to change your desktop to something
Oh, yeah.
really awful.
If you go to Shodan, you can find a lot of this stuff.
Yeah, it's just
Anyway,
like-
so SQL queries are there, and you'll be doing the SQL injection here in your projects. You certainly have to know how SQL injection works. It's the #1 most important vulnerability in the world. It's been at the top of the OWASP vulnerabilities, and OWASP is at the center of this course, the Web Application Security Project. They have script libraries you can download and learned treatises on everything. They're the primary group that researches and tries to fix all the web security problems, and right from the beginning, it's always been SQL injection. You might as well forget all the other problems and focus on this one. It's more important than all the rest put together.
The database is the holy grail.
Yeah,
Do they have like a certification program from OWASP?
they don't. It would be nice to.
Yeah.
But anyway, at least you got a project here where you can play with it. But yeah. Anyway, so XML is a way to just put things in machine readable form. Microsoft learned this. Microsoft Office used to have a separate proprietary binary format for Microsoft Word and Excel and PowerPoint, and they would change it every few versions, so it was totally incompatible with all the others. And then stuff happens like you get sued. They say, I want all the documents for the last 7 years having to do with your purchase of Java, and you can't even do a search for the query string Java to find them all because they're in some bizarre binary format, and you got Word perfect files and PDFs, and then you say, I wish we had a format where all the letters were just stored in plain ASCII text. And Microsoft wised up and they switched to XML. Now, all Microsoft Office documents ever since, I think, 2008 version of their stuff is all XML. So if you want to store anything, you just put it like HTML. You got a pet named Ginger, it's pet, Ginger/pet. You can have dog, spot, cat paws, whatever kind of data you want. Just put it in plain old ASCII text and put it in these tags. And now you can search it with the same simple text match and grep and find it. And this is great, and this is the way everything is. And of course, it's not very efficient for storage, so Microsoft Office documents are XML followed by zip to save space, and that's it. That's all they are. which is very nice. A huge step forward for Microsoft. And everybody else is pretty much wise on. So XML is a very common technique to move any kind of data over the network in nice, good old plain ASCII text that's easy to parse and easy to understand. SOAP is one of the many protocols that use it. A simple object access protocol just uses HTTP. So if you want to send something up to the server, you have posts, then you have text XML type, and down here you just have XML. And it starts with an XML tag, and then it has a SOAP envelope, and then it has get quotation, end of get quotation, and you just have whatever you want to say is just put in these tags, so it can be sorted into fields at the other end and used by the developer or put in database fields or whatever they want to do with it. It's just a nice way to format things. However, it is subject to XML injection, which I've used on the web for hilarious results. So, for example, here's something called Microsoft. You can see it's spelled wrong. So this might have come from the user. So suppose I could type in Microsoft, and then I could type in less than and put in this closing tag, and then put in a whole bunch of XML in this name. I have about the same problem with SQL injection. I could cause it to misinterpret this, and that has happened a lot. One of the big examples was security assertion markup language, which is used by mobile devices to pass your permissions back and forth. You can do XML injection and turn yourself into the administrator by adding extra permission statements to the statement that's going back to the server saying what you're allowed to do. Anyway, that's the problem. Anytime you take data from the user, there's going to be some bad data they could put in that would be an attack, and you have to filter it.
That's like something that comes down to coding too. It's like you were talking about like how you can have like so many crappy apps out there and all this stuff.
Yeah.
But a lot of it is like the level of diligence, like from a coding side, where you actually check your strings. You're like, oh, buffer overflow. You're like, well, maybe we shouldn't allow 3,000 random characters. That's
it. That's the trick. Every app has to not only think how to make it work, but also think what could go wrong and have a defense in there. And that's just a whole lot more work. But if you don't do it, you end up getting hacked.
Yeah.
So the SOAP response would look like this: 200 OK, so HTTP, and then just down there you've got XML responses. Just data structured the same way with tags, just put it into chunks. So that's SOAP. So if you build your SOAP request containing user-supplied data, then you ought to be filtering out things like less than and greater than, or you'll be sorry, as they can inject XML into it. There's a thing called Web Services Description Language, which servers use to advertise what services they offer. And there are tools like SOAP UI that will generate requests in the right format to match the descriptions coming from the server. So that's popular. It makes it easier to use. And we got some iClickers, and I think this is as far as I'm going to go today so everybody doesn't fall asleep. We'll finish this one next time. We may get onto the chapter after it. But anyway, this is enough for one day, I think. Which one is Microsoft's competitor with Java? Like I can quit at 25. All right, and that is ASP.NET. It's Microsoft's enterprise class server software. Big suite of tools. All right, which one uses HTTP and XML to exchange data? Quit at 25. That's SOAP. Good. And which one does LAMP use? Quitting at 25. All right, and that's PHP. Good, the most popular answer. Now, let me just say a word about the project. Let me just see where people are. I'm going to have score sheets up here soon, but I haven't got them yet. I'll have a score link here in the next week or so. But anyway, you should be doing your projects. Nothing is due for a couple of weeks yet, so if you haven't started your projects, there won't be any late fees or anything. But when you do turn them in, if you turn them in late, you lose 5 points. And if they're more than 2 weeks late, they're no good at all unless you contact me and let me know you're in the hospital or something. So you should start doing your projects, and you'll find them down here. I think I already showed you some of the command injection stuff last time I saw people doing them. Here's the SQL injection one. So I highly encourage you to pay attention to this one. This is where you do the attack and you get to see the defense. And you really should understand it because it is super important. And then you start playing with burp and Z-attack to get used to a couple of proxies. Burp is the main thing we'll use, but Z-attack is nice. And so do the SQL injection and also do the challenges. So you get beyond it. And I'm almost got my PowerShell challenge work. Microsoft put out PowerShell for Linux, and I got it working, but it doesn't work very well. It keeps crashing on my server. So that's kind of what you expect with an alpha product. But if I can get it working, I'll have a PowerShell injection challenge up there, which, anyway. So I'm going to quit recording this stuff, and then I'll just give somebody extra credit. If you get the most iClickers right, you get extra credit. This is 129S, Chapter 3B. All right.